Okay, Papa 2 friends, today you're going to learn how to solve radical inequalities by graphing. So we're going to start with number 1 here. Solve this inequality by graphing. The way you would do that is first we're going to graph this function here, the square root of negative x. So that's going to have like a vertex at 0, 0. And then since there's a negative inside of the square root, it's going to be reflected over the y-axis. So that means I'm going to go to the left 1, up 1, and left 4, up 2, left 9, up 3. And it goes this way. So that's my first graph. And now I want to find out when that is less than or equal to my second square root function here. This square root function has a vertex at negative 8, comma 8. So negative 8, comma positive 8 here. And it has an a value of negative 3, so that means I'm going to go to the right one, down 3. And then from the vertex, I'm going to go to the right 4. 1, 2, 3, 4, down negative 6. 1, 2, 3, 4, 5, 6. And then I can fit one more. So from the vertex, I'm going to go to the right 9 and down negative 9. So right here. And that graph looks like this. And now we need to figure out when is the square root of negative x, so this graph here, less than the second function that I graphed. And the way you do that is I always first find the intersection. So the two graphs intersect at negative 4. And then I can divide the graph into two sections, before your intersection and then after the intersection. So I'm dividing the graph into two parts. And before the intersection, it looks like the square root of negative x, so this one right here, the square root of negative x, is below the second graph. So here I'm going to write the square root of negative x is less than the 8 minus 3 square root of x plus 8. Now after the intersection, it looks like the square root of negative x, so this purple graph, is higher than, so it's going to be greater than the second graph that I drew. So after the intersection, my square root of negative x is going to be greater than the 8 minus 3 square root of x plus 8. So now I can answer the question, which just says when is the absolute value of negative x going to be less than or equal to. So it's going to be less than or equal to before negative 4. So I guess one way I could write it is I could put x is less than or equal to negative 4. However, you don't want to leave your final answer like that, because although the graph, although the square root of negative x is below or less than or equal to my second function before the negative 4, you can't just leave it to to negative infinity, because that second function isn't defined all the way to negative infinity. If you notice, the second function started at this vertex of negative 8 comma 8. So that means that the second function, like your answer can't go past negative 8, because again your second graph isn't defined for x values less than negative 8. So what we need to put is we need to put that x has to be greater than or equal to negative 8. Again, because for the second function, x cannot be anything less than negative 8. Like you can't put negative 9, negative 10, negative 11 for your x on the second function. So therefore, your final answer needs to be x is greater than or equal to negative 8, but less than or equal to negative 4. Or you could also put it in interval notation, negative 8 to negative 4. And that's how you would solve an inequality. You need to make sure that you're writing your answers with a reasonable domain. So that's what this is, a reasonable domain. For the second question, it's the same graphs, but this time you want to know when is the absolute value of negative x greater than the second function. So again, we already divided our graph and we already have the answer. It's going to be greater, the square root of negative x is going to be greater than the 8 minus 3 root x plus 8 after the intersection. So after x is greater than or equal to -4. But again, you can't just leave your answer like that because x can't be any number greater than -4. Specifically for the square root of -x, remember that that one has a domain restriction at 0, like it stops at 0. So therefore, your x has to be greater than or equal to -4, but it needs to be less than or equal to 0. And that's not how you want to write your answer. You need to write it as -4 is less than or equal to x, less than or equal to 0. Or if you prefer to write your answer in interval notation, the square root of -x is it's greater than, because we're doing number 2, it's greater than, so above 8 minus 3 root x plus 8 from -4 up into that vertex of 0. And I did right here a little typo. It wanted to be greater than, so it needs to be greater than -4, but not including the -4 because it says greater than and not greater than or equal. So let's put parentheses around that -4. And then, however, at 0, the graph is definitely greater than the second function, so that one we can leave it as an inclusive bracket. So that would be my answer for number 2. And now number 3 is the same kind of thing. So let's see. Go ahead and try to solve it by yourself first, and then I'll show you the answer. I need you to try to graph this square root function first, and then graph the line and figure out when is the square root function less than, so below, lower, less than the line. So pause the video to try to graph it on your own. Alright, hopefully you tried it on your own, and here's how you check the answer. The square root function has a vertex at -6, -8. 6, -8. It's got an a value of 2, so I'm going to go to the right one, up 2. To the right 4, 1, 2, 3, 4, up 4, 1, 2, 3, 4, and I can fit one more to the right, 9, 9, and then up 3 times 2 is 6, right here, and then that's all I can fit, so looks like that. And now the line is just the slope of -x with the y-intercept of, the slope is -1 with the y-intercept of 1. So here, the slope is -1, down 1 over 1, down 1 over 1, down 1 over, that's what they're intersecting, down 1 over 1, down 1 over 1. The other side is just up 1, left 1, up 1, left 1. Okay, so it's just going to be a line here. Again, the way you do inequalities is you go to the intersection and then you divide this graph, I guess, in half, left half, right half, and you start analyzing the graph. Before the intersection, it looks like the square root is less than because it's lower than. Remember, you look at the graph from top to bottom. So when you look at the graph from top to bottom, you first see the line, then you see the square root. So that means that the square root function here is going to be less than the line before you get to the intersection. Now, after the intersection, you notice if you look at the graph from top to bottom, you first see the square root function, then you get to the line. So that means that after the intersection, the square root function is greater than the line. So now we need to answer the question. The question wanted to know when is the square root function less than the line. So then we're looking at this case here. The square root is less than the line before the intersection. So the intersection was -3. So x is less than -3. That's when your square root is less than the line. But then remember I told you, wait, and it's not -3, it's +3. So x is less than +3. But then, like I said, x, you have to put a reasonable domain for x for this functions, and according to my square root function here, the vertex is at -6, so x can't be anything less than -6. Like you can't put -9 or -10 because then you're taking a square root of a imaginary stuff, a square root of a negative number, which is imaginary. So we do need to put a domain restriction here, which says x has to be at least -6. So then your answer in set notation could be -6, less than or equal to x, less than 3. Or you can use interval notation and put a bracket at -6, which means inclusive, because at x equals -6 is definitely less than the line. and then 3 with a parentheses, because at x equals 3, the line and the square root are equal to each other, so we don't want to include it since it just says less than. So here's my answer in set notation and in interval notation. Definitely practice these for your progressive test and just solve the inequalities by graphing. Now the next one is just some application problems, which just means word problems. So let's try number 4. Isabel accidentally dropped her keys from the top of the Ferris wheel. The formula t equals 1/4 square root of d minus h describes the time, so t is time, in seconds at which the keys are h meters above the ground. So h is the height of the keys, and Isabel is d meters above the ground. So d is the height of Isabel. If Isabel is 65 meters high, so that's telling me that d is 65. When she dropped the keys, how many meters above the ground will the keys be? So we're looking for h, after 2 seconds. So clearly when t is equal to 2. So now we just need to plug everything into the formula here. So t equals, so we're going to put 2 equals 1/4 square root of d was 65 minus h, which is what we're looking for. So now just do some algebra here to solve for h. So to solve a square root function, we isolate the square root. So multiply by 4 to get rid of the 1/4. So 2 times 4 is 8. Square root of 65 minus h. You can get rid of the square root by squaring both sides of this equal sign. Let me put that over here. Let me put it over here. So that's going to be 8 squared is 64. The square root of 65 minus h. If I square that, it's going to cancel your square root, so it's just 65 minus h. And if I solve for h correctly, you just get h equals to a positive 1. If you correctly subtract 65 and divide by this negative. So it looks like the keys would be at, I guess, 1 meter. 1 meter. So you can include the units there. And the last one here is number 5, same kind of like just word problem. What are the lengths of the sides of this trapezoid here if the perimeter of the entire trapezoid is 17? So that basically means if I were to add all 4 sides, it needs to equal to 17. So I'm just going to add the 2 square root of x plus the x plus the 2 square root of x plus the x plus 1. And that needs to equal to a perimeter of 17. So now you're just going to simplify, combine like terms, and solve for x. So this is going to be 4 square roots of x plus 2x plus the 1 equals 17. And then to solve a square root function or a square root equation, we need to isolate the square root of x here. So I'm going to bring the positive 1 to the right, and the same thing with this positive 2x to the right. So I'm going to put 4 square root of x equals minus 1. So 17 minus 1 is 16 minus 2x. And one thing here that I can do, I could divide by 4 so I can isolate this the square root of x completely, but I'm just going to divide by 2 so that I can square the stuff better. So I'm just going to divide this side by 2 and that side by 2, and I'm going to be left with 2 square root of x equals 8 minus x. Okay, now at this point, I'm going to leave the 2 there and just square it correctly. So I'm going to square the left side and square the right side so I can solve for x. I'm going to bring that over here so I can have more room. So when I square 2 square root of x times 2 square root of x, that's going to become 4x, because 2 times 2 is 4, and the square root of x times the square root of x is x. And that's going to equal to 8 minus x squared. So that's 64 minus 16x plus x squared. And that's just the quadratic now, so I can make it equal to 0. 1x squared minus 16x. No, it's not minus 16. I need to do negative 16 minus 4x. So minus 20x plus the 64. And now I just need to factor that. It's going to be x for sure, x times x, and then 64 16 times 4 is 64, and if I make them both negative, they will add up to a negative 20 like I need. And now I'm going to have solving for x. X is equal to 16 and x is equal to 4, and I need to now actually answer the question. The question was find the length of the trapezoid. So let me turn on my screen again because it went dark. Alright, so I need to see if these answers are reasonable. So let's start with the x equals 16. So just by looking at this trapezoid, x can't be 16 because you can't do like 16 and 16 plus 1 and give you a perimeter of 17. Like, that's not a reasonable answer, so x can't be that. Let's try 4. It looks like x could be 4, and then if I find the actual size, the 4 sides of the trapezoid, it's going to be 4 is one of the sides, 5 is another one. Here, this would be 2 square root of 4, so that's going to be 2 times 2, so that's another 4, and same thing here, that's another 4. So I guess if I were to add 4 plus 4 plus 4 plus 5, that does give you a perimeter of 17. So that's today's lesson. You need to practice a couple of the word problems on this worksheet and also practice the inequalities by solving by graphing. And do some practice.